65 days. It is a number that now sits at the very heart of the confounding Nancy Guthrie investigation. And for those who have tracked this case from the start, the weight of that number is unmistakable. It marks 65 days since a woman disappeared from the sanctuary of her Tucson, Arizona residence. 65 days since a motion-activated camera captured what authorities now suspect was a carefully orchestrated departure. 65 days of silence. But tonight, this is what we know for certain. This is not a recap of the basic facts. Our focus tonight is singular and critical. Federal investigators have officially confirmed the recovery of DNA from within Nancy Guthrie's home DNA that is foreign to her and to anyone in her inner circle. A search of CODIS, the nation's vast criminal DNA database containing profiles of over 20 million convicted offenders, has produced no match. And yet, there have been no arrests, no suspects named, no charges filed. It begs the question, where does the investigation truly stand? What is the status of that DNA? And why has the most crucial piece of forensic evidence in this entire case, evidence that is both confirmed and in existence, evidence currently secured in a federal laboratory, failed to identify a suspect after 65 agonizing days? Tonight, we provide an answer, not born of speculation or rumor, but from the expert who has resolved over 300 cold cases employing the very science now directed at the DNA found in Nancy's home. C.C. Moore, a leading genetic genealogist with Parabon Nanolabs, provided the most thorough public explanation to date for why this investigation has stalled at the very point everyone expected a breakthrough. Her insights are precise, her expertise is direct, and the information she reveals will fundamentally alter your perception of this entire investigation. First, let us examine where the investigation stands at this critical juncture. The established facts of this case paint a grim portrait. 84-year-old Nancy Guthrie, mother of Today anchor Savannah Guthrie, was reported missing in February 2026 from her Tucson, Arizona home. A call that began as a simple wellness check swiftly transformed into a major criminal investigation. The response mounted by law enforcement is atypical for a missing persons case. Its scope is federal. Multiple agencies are involved, and the sheer volume of resources deployed signals the gravity of what authorities believe has occurred. On the record, the Pima County Sheriff's Department has confirmed these details. Unidentified DNA was retrieved from inside Nancy's residence, and it has been verified not to be hers. It has been ruled out against her inner circle, and a search of the national CODIS database came up empty. The evidence is now in federal custody. What the Pima County Sheriff's Department has refused to disclose, with remarkable discipline, are the specifics: the method of collection, the surface it was found on, its quantity, or any theories about when it was left behind. This calculated silence, however, speaks volumes. When investigators are forthcoming, it often signals they have little to lose. But when they fall silent, it typically means they are safeguarding a live and critical trail of evidence. Throughout this investigation, Sheriff Chris Nanos has been subjected to intense and specific scrutiny. This scrutiny, which has been covered in depth elsewhere, concerns the consistency of his public statements and the management of initial evidence. That ground will not be revisited tonight. The focus here is the forensic landscape as it currently exists. The evidence is real, it is undergoing analysis, and that analysis is not yielding a quick resolution. The fundamental question we address tonight is simple: why? Before we explore the science, one more piece of context is crucial. Ashley Banfield's Drop Dead Serious podcast has remained a key source of reporting on this case, utilizing law enforcement contacts speaking under the condition of anonymity. Banfield has stated, citing these unnamed sources, that insiders described the DNA evidence within Nancy's home with a single, telling word: complicated. That one word, complicated, is where C.C. Moore begins her explanation of what this DNA truly is. When the Pima County Sheriff's Department announced the lack of a CODIS match for the DNA found in Nancy's home, many observers mistakenly viewed this as a dead end. It is not. To understand why, one must first grasp what CODIS is and what it is not. The Combined DNA Index System, or CODIS, is a national database managed by the Federal Bureau of Investigation. It stores the DNA profiles of over 20 million individuals, consisting mainly of convicted felons and those arrested for qualifying offenses in the U.S. If an individual's DNA profile exists within CODIS, a match can occur quickly, sometimes within hours. but the key qualifier is if. CODIS exclusively contains profiles of individuals previously arrested for or convicted of certain crimes, where DNA collection was part of the legal process. The database does not include the general public. It excludes anyone with a clean criminal record, and crucially, it does not include the tens of millions who have voluntarily used consumer DNA services like 23andMe or Ancestry. The lack of a CODIS match presents investigators with one of two distinct possibilities. The first is that the individual whose DNA was recovered from the home has no prior record of a qualifying offense anywhere in the United States. The second, and the possibility forensic experts are focused on far more intensely, is that the sample from the scene is what the scientific community calls a complex mixture. A complex mixture is precisely what its name implies. Instead of isolating the genetic material of a single person on a given surface, investigators are contending with a sample that holds the genetic traces of multiple people, several contributors, all commingled on the same surface and collected in the same swab. This scenario is not at all unusual in crime scene forensics. Every surface a person touches, a doorknob, a light switch, a railing, accumulates biological material over time. These surfaces essentially become archives, collecting the genetic contributions of every individual who has ever made contact. Standard two-person mixtures, in which forensic labs are tasked with separating two contributors, are quite manageable with current technology. Most labs possess established protocols for the deconvolution of two-person samples. But the DNA recovered from Nancy Guthrie's home, based on what C.C. Moore has described from her direct sources, is far from a standard two-person mixture. It is a complex mixture, with potentially 3 or more contributors, where the suspect's profile could represent as little as 10% of the sample's total genetic material. But if analysts were to report it's 10%, or that it contains 4 unknown males who are each only 10% or 5%, that sample is profoundly unlikely to ever be the evidence that solves this case. Consider for a moment the practical implications of that number. Out of every 10 units of genetic information contained in that sample, 9 could very well belong to people who were legitimately in that space. This could be Nancy herself, members of her family, regular visitors, contractors, or caregivers, while only one single unit belongs to the person who was not meant to be there. To isolate that 10%, to computationally extract the genetic signal of one unknown individual from a background of known biological noise, is one of the most formidable problems in modern forensic science. And there is a second layer of difficulty that makes this challenge even more complicated. The question is not merely whether investigators can identify the suspect's profile from this mixture. The far more critical question is whether they can produce the specific type of genetic profile that is necessary for genetic genealogy. And as the DNA expert C.C. Moore makes clear, those are two entirely different questions. In this conversation, one name currently carries more authority than any other: C.C. Moore. C.C. Moore is the chief genetic genealogist at Parabon Nanolabs, the preeminent company in the field of forensic genetic genealogy in the United States. If you have followed any serious true crime coverage over the last 5 years, you have undoubtedly encountered her work. She is credited with contributing to the resolution of more than 300 cold cases investigations, with no suspects and no active leads, some of which had seen decades of silence, by applying genetic genealogy to DNA that had sat for years in evidence lockers. She is the most credentialed voice in this specific domain of forensic science, and she spoke directly to TMZ regarding the Nancy Guthrie investigation. What she stated was not what most observers in this community anticipated hearing, and its significance lies not just in the details she revealed. It is rooted in the fact that she revealed anything at all. C.C. Moore does not publicly speculate about active investigations without a solid foundation. When she outlines the mechanics of why this particular DNA has not yet produced a suspect, she is describing a problem that she understands intimately from the inside. In substance, here is what she conveyed to TMZ. The sample taken from the home is a complex mixture, not a simple one, she emphasized, but a complex one. The challenge with complex mixtures, specifically when attempting to use genetic genealogy, as opposed to traditional DNA matching, is that the entire scientific basis shifts. And based on the information available, this has all the hallmarks of a complex mixture, which signifies that more than 2 people are present in it, and very likely, more than 2 unidentified individuals. Traditional forensic DNA analysis, the method used for CODIS matching, relies on what are known as STR profiles, or short tandem repeats. These constitute a specific collection of genetic markers, standardized throughout the field, which creates a kind of genetic fingerprint. Labs are proficient at handling complex STR mixtures, as the technology and software have been refined over decades. Even with a difficult mixture, trained analysts can frequently isolate an STR profile for the minor contributor, the one with the smallest percentage, and then run that profile against CODIS. Genetic genealogy is different. It does not employ STR profiles. It utilizes SNP profiles, which stands for single nucleotide polymorphisms. A SNP profile necessitates hundreds of thousands of genetic markers spread throughout the entire genome. It is an exponentially richer and more detailed genetic map, and it is that richness, that sheer density of data, that allows genetic genealogy to function so powerfully. Because when you upload a SNP profile to a consumer database, you are not simply asking if this specific person has a profile stored there. The process begins by querying the database to identify every individual who shares significant segments of that person's genetic code, parents, siblings, and extending outward to cousins, even third cousins. From those genetic matches, the algorithm constructs a family tree, allowing investigators to trace lineages backward and ultimately pinpoint the identity of the unknown subject. Yet, this is the very problem C.C. Moore is outlining. The deconvolution methods proven effective for STR profiles are not directly applicable here. The computational process of isolating one contributor's DNA from another within a mixture does not currently function in the same capacity for SNP profiles. The very algorithms that empower laboratories to distinguish a minor STR contributor from a convoluted mixture have yet to be replicated for the SNP analysis essential to genetic genealogy. The technology required to produce an unadulterated SNP profile from a minor contributor within a complex mixture remains elusive. The ability to isolate the contributor who makes up just 10% of the sample does not yet exist on a scalable level. This is the scientific barrier obstructing the investigation, the profound challenge of complex mixtures. To truly understand the impasse, we must venture one level deeper into the science, for it is here the explanation resides, and where much of the public discourse has lacked critical precision. When forensic scientists set out to create an SNP profile for the purpose of genetic genealogy, they employ a technology known as either microarray analysis or low-pass whole genome sequencing. Both of these methodologies yield readouts covering hundreds of thousands to millions of specific locations within a person's DNA positions, where single nucleotide variations differentiate one human from another. The data file that results from this process is the very information uploaded to consumer databases to search for genetic relatives. At its core, the challenge presented by complex mixtures is an issue of signal-to-noise ratio. Imagine attempting to discern the sound of a single violin within an orchestra where 9 other instruments are playing with greater intensity. That violin representing the minor contributor, the suspect is technically a component of the overall acoustic environment. While the sound waves are physically present, cleanly separating that specific signal to reconstruct its melody is an engineering puzzle that has not been fully solved at the SNP level. For STR analysis, laboratories have engineered sophisticated probabilistic genotyping software to navigate this. Programs such as TrueAllele and STR-Mix are designed to model these complex mixtures, calculating the statistical likelihood that a specific array of genetic markers belongs to a minor contributor. These instruments have been validated in courtrooms nationwide and have secured convictions in cases where conventional interpretation methods would have been futile. However, these powerful tools were constructed specifically for STR profiles. Their operation is confined to a limited number of targeted markers, not the vast, genome-wide data demanded by genetic genealogy. At the SNP level, the problem of deconvolution becomes exponentially more complex. When a lab generates SNP data from a convoluted mixture, the output is a distorted signal, where every genomic position is an amalgam of contributions from all individuals present. At a single position where the suspect might possess one allele, a specific genetic variant, while a more dominant contributor possesses a different one, the signal from the mixture can entirely eclipse the suspect's genetic signature. This yields an SNP profile of the mixture that is fundamentally unreliable and therefore cannot be uploaded for comparison. Genealogy databases mandate clean, diploid profiles, A profile derived from a mixture inevitably fails to meet these stringent quality thresholds. This is not an indictment of the investigators, the FBI, or the laboratory. It represents a formidable technology gap. The tools available today were never conceived for this particular challenge. Traditional DNA forensics and genetic genealogy evolved on parallel tracks, each solving different kinds of problems. The convergence of these two distinct disciplines applying genetic genealogy to complex forensic mixtures is the absolute cutting edge of the science right now. And the cutting edge, by its very nature, is a place not yet fully formed. C.C. Moore's assessment of this predicament reflects a stark technical reality that the wider forensic science community is diligently working to overcome. In terms of the scientific hurdle it presents, this case is not an anomaly. It is, however, unique in the sheer volume of public pressure and resources it has commanded, and that very pressure is now accelerating the development of fast-tracked software solutions. It is at this juncture that the story becomes highly specific, and we will be meticulous with our sourcing, because in matters like this, precision is paramount. C.C. Moore stated to TMZ, on the record and in her own words, that her sources with direct knowledge of the case have informed her of something significant. They revealed that new software is in active development, its progress fast-tracked precisely because of cases like the one involving Nancy Guthrie. She identified a potential company spearheading this effort, a firm known as Othram, hinting at a new deconvolution software package, possibly from their labs. I have even received recent information suggesting that specialized equipment is slated for release in about a year's time that will be able to assist with this, and that is an exceptionally rare development. To be perfectly clear, this information is from C.C. Moore's reporting, sourced from insiders. It is a single-source claim. We are not independently confirming the Othram assertion. We are attributing it to its origin. C.C. Moore, on the record, speaking to TMZ. But the fundamental substance of what she describes is deeply significant. The dedicated effort to create SNP mixture deconvolution software, tailored for forensic genetic genealogy, aligns perfectly with the objectives researchers in this field have pursued for years. Within the scientific community, a well-documented chasm exists between analyzing traditional, complex DNA mixtures and the newer, powerful methods of SNP-based genealogy. For years, research teams across both government and private forensic sectors have been grappling with how to bridge this divide. But C.C. Moore's statement does something more. It attaches a name, a specific case, and a clear timeline to that monumental effort. Here we have a company, a victim, and a palpable sense of urgency. Assuming her information is sound, and she has no conceivable motive to misrepresent it, especially with her own name and professional standing inextricably linked to the claim, the Nancy Guthrie case is doing more than just drawing on established investigative tools. It is forcing the very creation of new ones. Let the weight of that reality sink in. The disappearance of an 84-year-old woman from Tucson, Arizona, is generating such a powerful wave of investigative and scientific pressure that private companies are being compelled to fast-track the creation of technology that is not yet commercially available. The influence this case is exerting upon the forensic science world is no mere coincidence. It is a direct consequence of who is watching and who is demanding answers. C.C. Moore's own projection for when this software could become operational is measured in months, possibly even a year, not in the coming weeks. This isn't a scenario where a new program is released and the case suddenly breaks wide open next Tuesday. It is, however, a scenario where a viable path forward has been identified, where someone is painstakingly constructing the very road that will lead investigators to their destination. And that fact profoundly alters our understanding of this investigation in the present moment. Because any narrative of a stalled investigation, of detectives sitting on crucial evidence and taking no action, is fundamentally flawed. What is truly underway is a race pitting a case with a biological answer entombed in a mixed sample against a scientific discipline scrambling to forge the key. The fact that this key has not yet been created does not mean the door will remain locked forever. It means the timeline is currently in the hands of engineers and geneticists, not prosecutors, while the FBI's genealogy unit remains on standby. Yet, the FBI doesn't merely have a single genetic genealogy unit. It possesses something far more structured and formidable. The Bureau's forensic science strength in this field functions through its laboratory's DNA analysis unit, working in concert with the FBI's investigative genealogy program, formally created in 2019. This program was brought into existence for the specific purpose of applying the developing science of genetic genealogy to federal criminal inquiries. Its mission: to take the consumer database matching techniques that C.C. Moore and others pioneered in the private industry and integrate them into a federal law enforcement apparatus. C.C. Moore stated unequivocally to TMZ, "The FBI genealogy team is standing by and ready to work night and day the moment a viable SNP profile can be generated from the Nancy Guthrie evidence." And this is because the FBI's genetic genealogy team is primed for exactly this moment. There is no ambiguity. If they secure that viable SNP profile, they will be working relentlessly on the problem. That is not a vague expression of hope. It's a declaration of operational readiness. A team with the expertise, the legal authority, and the institutional directive is in position, waiting for a single scientific barrier to be broken. The legal architecture governing what will happen next is crucial to comprehend. The FBI lacks unrestricted entry into consumer DNA databases. This is a vital distinction often obscured in the public discourse surrounding genetic genealogy. 23andMe, Ancestry, and other dominant consumer services operate under their own terms of service and data governance rules, some of which include explicit prohibitions on law enforcement access. GEDmatch and Family Tree DNA are, at present, the two principal platforms that permit law enforcement uploads, but only under strictly defined protocols. Since 2020, the use of genetic genealogy by federal law enforcement has been dictated by interim guidelines from the Department of Justice. These guidelines mandate that federal agencies can only deploy this technique in cases of violent crime or for identifying human remains. Secondly, they must secure approval from a supervisor. Thirdly, they must meticulously document and monitor all genealogical leads. And fourth, they must use only those database platforms with established policies for law enforcement cooperation. The disappearance of Nancy Guthrie is being treated as a violent crime investigation. It satisfies every necessary condition for the use of federal genealogy resources. The one thing it still lacks is the SNP profile, the essential data that the entire downstream operation depends on. This constitutes a single, critical bottleneck, and it is a bottleneck that exists squarely in the domain of forensic science, not because of any lack of will or legal power on the part of law enforcement. So the image that emerges is of an FBI team trained, authorized, and poised to act. It is an image of a legal framework that permits them to proceed. A consumer database network holding tens of millions of profiles, accessible under specific circumstances, and a suspect whose genetic signature is held inside a federal laboratory, trapped within a complex mixture, waiting for a computational key that is still weeks or months away from its own creation. This constitutes the complete picture. It is the state of the investigation as defined by the limits of current science. Now, we must consider what unfolds the moment that key finally arrives. The answer, which C.C. Moore stated explicitly on the record to TMZ, represents the single most significant public statement about this investigation in weeks. The revelation: 50 million profiles. 50 million. That is the number. This is the figure C.C. Moore cited, on the record, during her TMZ interview while describing the potential magnitude of what investigators stand to access. This is contingent on the extraction of a viable SNP profile from the sample recovered from Nancy Guthrie's home. Despite the reality that over 50 million individuals have used direct-to-consumer DNA tests, the three most prominent companies have expressly forbidden law enforcement from accessing their databases for these purposes. 50 million DNA profiles, dormant in consumer databases, scattered across the United States. These belong to people who mailed in a saliva kit, hoping to learn of their ancestry. They are individuals who sought to understand their health risks, or people attempting to locate biological relatives. Not one of them offered their DNA for the purpose of solving a crime. The vast majority are unaware that under very specific legal circumstances, with the proper investigative tools and judicial authorization, their genetic information, or more accurately, the familial connections their genetic data exposes, can be used to pinpoint someone who never submitted a sample at all. This is the core mechanism of investigative genetic genealogy, and it is a concept worth examining closely, as public comprehension of it remains persistently flawed. When authorities upload a suspect's SNP profile into a genealogical database, Their search is not for a direct match to the suspect's own profile. They are searching for the suspect's relations, individuals who share significant segments of DNA with the unknown person. Parents, if their data exists in the system, along with siblings, aunts, uncles, and first cousins. Even second or distant fourth and fifth cousins can prove crucial if they share a sufficient number of genetic markers. After investigators pinpoint these relatives, a genetic genealogist, a person with C.C. Moore's specialized expertise, begins to construct a family tree, branching outward from every match. The objective is to discover the common ancestor shared by the match and the unknown profile, then to trace the lineage forward through time, identifying all descendants of the correct age and sex to be the suspect. From there, investigators cross-reference these names against other leads' geography, existing records, prior contacts, to methodically shorten the list. The Golden State Killer case, which broke in 2018, was what introduced this technique to the world. Joseph James D'Angelo was located through the DNA of a distant cousin, which had been uploaded to GED Match. His own DNA was absent from any law enforcement database. He had completely circumvented CODIS. But his family members, people utterly uninvolved in his crimes, with no inkling they shared DNA with a serial killer, were present in a consumer database. And that connection was all it took. C.C. Moore conveyed to TMZ that if investigators managed to generate a usable profile from the Nancy Guthrie evidence, if the complex deconvolution puzzle is solved and a clean SNP output is achieved, the FBI's genealogy team will then pursue warrants to gain entry into the major consumer DNA databases. And should those warrants be granted, should those databases be opened, the suspect would be identified not in years or even months. This is why I hold the belief that if they can secure that viable SNP profile, one they can upload to genetic genealogy databases for this case, they will absolutely serve warrants on those large companies in an effort to find him faster. This means the individual could conceivably be identified in minutes, hours, or days, as opposed to weeks, months, or years. The timeline shrinks to minutes to days. That single breakthrough is the pivot point. The entire investigation, every press briefing, every physical search, every tip line call, every forensic team dispatched to Tucson, all of it narrows to one pivotal scientific moment. It is the moment a clean SNP profile can finally be isolated from a complex mixture that, as of now, refuses to yield one. That moment represents the chasm between 65 days of silence and an identification that could occur in less time than it takes to process a passport application. The technology is under development. The specialized team is on standby. The databases are full. The legal precedent has been set. The only component that remains missing is the key that will make the biological evidence confess its secrets. And this is where the narrative must pause for tonight. There can be no neat conclusion to a story that has not yet concluded. There can only be clarity on its current position and a frank acknowledgement of what is required to force it forward. The DNA from Nancy Guthrie's residence is real. That fact is confirmed. It rests in federal custody. The lack of an arrest, based on everything we know from the most authoritative source available, is not the result of some investigative misstep. It is the result of a technological impasse, a problem configured in a way that has never been seen before. A complex mixture, containing a minor contributor profile at a concentration of potentially 10%. It is a field of forensic science where the destination is clearly marked on the map, yet the very road to reach it is still under construction. What C.C. Moore has accomplished by speaking out, by attaching her own name to this explanation, is to grant this community a form of transparency rarely seen in active investigations. She has provided an unvarnished look at the why, a dimension far deeper than the simple facts of the what or the who. The reason 65 days have now passed with no one in custody, the reason crucial evidence exists, yet the case itself remains frozen in time. And the reason why the answer, when it finally arrives, will likely emerge with a velocity that seems impossible given all the silent days that have preceded it. What is understood, and what we will be observing in the coming weeks, is whether the development timeline for the Estros software can be compressed, whether any other forensic methods might yield a result before these new instruments are fully operational, and whether investigators are pursuing parallel evidentiary threads that could break the case on an entirely different schedule. The DNA is not the only piece of this puzzle. It is the most discussed piece of evidence, but it is far from the whole story. If you possess any knowledge about this case, anything that has been verified, Anything you have personally witnessed, or anything publicly documented that remains unexplored, please leave it in the comments. This community has been instrumental in surfacing leads that are taken seriously. We examine every comment, we follow every thread. Nancy Guthrie has now been missing for 65 days. The investigation is ongoing, the evidence is secured, and the science is moving forward. We will be back. This video is produced for informational and investigative journalism purposes, based on publicly available records, named on-record sources, and documented media reporting. No individual has been named as a suspect in the disappearance of Nancy Guthrie. The analytical conclusions drawn in this video represent our editorial interpretation of the available facts and are clearly labeled as such. Claims from a single source are attributed with appropriate caution. This production does not fabricate information, speculate about named individuals without a verified basis, or produce content intended to harm any person's reputation. If you have verifiable information relevant to this case, contact the Puma County Sheriff's Department tip line at 520-351-49. For grief or crisis support, please contact 988.